Hello everyone, so today we are talking about the Stackr SDK, and the agenda for the video is to build a micro-rollup from scratch using the Stackr SDK, hopefully in under 5 minutes. So the steps that one needs to follow to build a micro-rollup are these. You initialize the project, then you define the rollup state, you define the user action, you define the state transition rules, and then finally you initialize a micro-rollup. Once these steps are done, you just deploy the micro-rollup and run. Let's get started. So the first step, which is to initialize the project, looks like this. So you use the Stackr CLI to initialize a project. And once it's ready, it should give me an option to select a template. Right now we'll select empty, and I'm going to name the project counter because the rollup that we'll be deploying is a counter rollup that's going to increment or decrement the counter state based on users' inputs. So it's set up now. I'm going to cd into the directory, and I'm just going to copy my environment variables which I created in my previous project. And once this is done, I'm going to use the CLI again to register my micro rollup to Stackr's registry. That is an on-chain registry, and it will also deploy a contract for my rollup that the rollup will use to put its blocks on. So once this is done, it should generate a deployment file which looks like this. So it gives me an app ID which is 42, and it will give me an app inbox which is deployed at this address. So yeah, step 1 complete. The next step is to define the rollup state, and we'll do that using the code editor. So once it is set up like this, I'm going to come here, I'll get into the Stackr directory, and I'll find a couple of files here. I'll also create one more which is called transitions.ts so that my directory structure is clean. Inside the machines, I'm going to create a counter state which will look like this, and this extends a utility class with Stackr, and this state is a number because I'm going to work on just a single integer. And what it does, it's going to take a constructor which is going to be state again, and it's going to be numbered, and it will call super, which is the super state, and we'll just initialize it with state. One more thing that I need to do is I'm gonna have to define how I'm calculating the root hash, and this is custom and every state needs to define one. So right now I'm just gonna return a solidity keycheck 256 of the state itself because it's a very simple state. If you have complex states, you might have different logic to define your state root function. So once this is done, I'm gonna create another constant called machine, which is my state machine. So this is just going to be new state machine, and this is something which comes from Stackr again, and this takes in a bunch of things, which is identifier, the ID. I'm just going to call it counter, and it's going to take the state class which we just defined, which is counter state in this example. The other thing that's going to take is initial state, and this is interesting because we provide a genesis state.json file over here which defines your genesis state. Over here we are just using integers, so I'm just going to put it to 0, so my counter will be initialized from 0, and this genesis state is also something which gets deployed on chain during deployment. So your genesis state of the rollup is set. You can pick whatever genesis state you want over here. So I'm going to import that like this, and I'm going to pass it on like this, genesis.state. And the other thing that it takes is an on method, and this expects me to provide it state transitions, which I'm going to provide in just a minute. One more thing that I'm going to do is export my state machine like this. So export machine, and make sure that this is a named export because that is how our compiler knows that this machine is exported from your function. So yeah, that's step 2. Step 3 is defining the user actions. So user actions are basically custom transaction format that a user can define. I'm going to create another constant, and I'm just going to call it update counter, and I'm going to create a schema for that. And the schema is again a utility function from Stackr SDK, and this takes in a couple of things. So if you hover, it takes in an identifier and it takes in a schema. So I'm just going to give it an identifier of update counter, and the schema is just going to be a timestamp for now. So I'm using timestamp because I want my action to be unique. So this is a nonce replacement, and also my state transition functions are not going to take any other input. You can define any sort of input over here. It could be like 5 inputs, 10 inputs, doesn't matter. So I'm going to use the increment and decrement state transition function, which will both have the same schema like this. So I'm happy with this right now. So yeah, that's it. That's step 3. Step 4 is defining the state transition rules. So over here inside the transitions file, I'm just going to come in and just define my state transition. So one is going to be an increment. So increment is an STF which takes in my state, and how I define it is by doing a handler which gives me a bunch of things, which I'm going to show just now. So my handler provides me a couple of options. So I can take in inputs, whatever my schema is giving me. So right now it's going to be timestamp, which is not going to be used. But if you have other inputs, you can get it from here. It will also give me a message sender, whoever sent that action. It will give me a signature on this action, and it will also give me a state. So I'll just use state for now. And since it's an increment, I'm just going to increment the state like this. And once this is done, I'm going to return the state like this. So yeah, that's my state transition rule. I'm also going to do a decrement, and inside decrement it's going to be very similar, but what I'll do is I'll add another check. So I'll do a require, which is a utility function. So the state should be greater, so basically the state can never go below 0. So I'll just do this. So if I subtract state like this, it's gonna throw an error like this, and it will basically fail my state transition rule like this, because I don't want negative numbers over here. So yeah, that's pretty much it. And I'll just export these things inside a wrapper. So export const transitions, and these are transitions on counter state, and it will basically take an increment and a decrement like this. Yeah, that's pretty much it. So I defined my state transition functions, and the final thing that I'm going to do is initialize the micro-rollup. So before that, I just need to pass it on to my state transition. Pass on my state transition to the state machine. Also, it is important to know that state machines and the rollups are independent of each other. So a rollup contains a state machine, but a state machine could be an independent entity on its own. So we just define the state machine. The next step is to define a rollup, and I'm going to do this like this. So I just define a main function, which will be an async function, and I'll just call a main function like this. And to define a rollup, what I need to do is create a constant. So MRU micro-rollup, and this micro-rollup takes in a bunch of things. Config. So the config is Stackr config, and I'll just show what's there inside Stackr config. And the other thing is the actions, and this action is basically what we just defined inside the action, which is update counter schema. The next step is to use the MRU and attach a state machines to it. So I'm just going to add a state machine like this, which is just going to be machine, I believe. Yeah. And once this is done, I'm going to use MRU.init, and this will basically start my micro-rollup. And yeah, that's it. That's pretty much it. So you just initialized a micro-rollup, and the final step is to run it. So to run it, what we need to do is get back here, and we need to send an action to the MRU. So I'm just going to copy a boilerplate code from here, because this stuff is not mandatory. It's going to come from the front end anyway, but I just created a utility so that I am able to create actions and send it to the micro-rollup. So I just create a wallet, let's give it some types, and I'm not going to use it like this. I'll just hide it, and over here inside it is interacting with the MRU, and over here I need to create a input. I'll just copy some more stuff from boilerplate like this. So I'm just creating an input which includes a timestamp, which is the current timestamp. Then I create a signature using my function which I created above. So the sign message takes in a wallet, the update counter schema, and inputs. Behind the scenes, it uses EIP712 to create a signed message data, and I'll just create an action using it. So I'll use the counter schema and create an action from, and it takes in inputs, signature, and message sender. And this increment action is on the MRU. So if I do MRU.submit action, provided the state transition function that I want to call, which is increment in this case, it could be decrement also, and then I'm going to provide it increment action. What this will return me is an acknowledgement, and this acknowledgement is logged over here like this. So yeah, so inside the run thing, the next step is just to deploy. So npx deploy. So this utility will just compile my rollup. So it's building the state machine, it's extracting all the state machine logic and compiling it into WASM. Then it is registering the state transition function to the app inbox. And once that is done, it should send it to Vulkan. So Vulkan is the verification layer, which will take its WASM and store it with itself. And once this is done, you are ready to run your rollup. So I'm just going to do one run, and I'm just going to call index. And this is basically a micro-rollup that is started. And my action was submitted over here like this. So this is the acknowledgement for my action. So it created a new batch with one action in the batch, and it created a new block from that batch. The block contained one action, which is increment, and we received an action confirmation C1, which is basically your state was updated. And yeah, so it sent it to Vulkan, and it received a Vulkan confirmation from it, so verified the block. And if you wait a couple of more seconds, it will send its data to L1 and will be receiving a C3 confirmation from it. So C1 was execution, C2 was Vulkan verification, and C3A is DA, and C3B is L1 confirmation. So it's just going to take a couple of seconds. Yeah, so Yeah, it basically depends on the speed of the DA layer, and for right now we are using avail behind the scenes, and its confirmation time is about a minute. So, and the block time is about 20 seconds. So if we wait a little bit more, yeah, so we just received that. So we received settlement confirmation C3B and block settlement state updated for block at height 1. So the first block was settled on chain on L1. Basically, this is how you create and run your own micro rollup, and we will be releasing beta very soon. And yeah, thanks for watching.